Hi, um, I'm going to finish this what I started yesterday. I've been a bit sleepy because I fell. I think I dozed off in front of the TV. But I wanted to finish this. So yeah, Gauss found Gauss found the equation that described this because he was playing with this exponential equation mm, based on I had something. Hold on. Gauss was playing, I told you, with this equation, with this y equal e x, right? The exponential increase and also the exponential decrease. The same with a minus, okay? But he saw that they didn't match because this one, yeah, when x equals 0 was 1, and this when x equals 0 was 89. So I had to kind of modify the equation to try to, because the intuition is that this equation had the same form when he plotted. So let's go back. So when he found that that was not the day one, right? Because since it was the initial value and the time didn't start, he had to switch it to 0. That's the first thing he noticed. And then the exponential decrease had the same shape but not the same magnitude. It didn't coincide neither the curvature, how fast it fell, okay, neither the how big it was. So his intuition was that there were two coefficients. So if we call the day, we call it x, right? And the number of samurai alive, call it n. Call it, no, this is really a time, right? The day, call it time, okay? T, and the samurais alive, call it n. So instead of a general equation, general y and x is n versus t. His intuition was that when t equals 0, this should be the initial number, this value, okay, and then the shape, how fast samurais were dying. There was an additional factor. It was related to the chance. It was a 50% every day. So if it had been like a dice, 1 in 6 to die would have been lasted longer, and just tails and heads, it made them die faster. So there was another coefficient here, let's call it alpha, okay, that from the general equation, okay, tell us about the rhythm, how fast the action is. Yeah, so his intuition was that the initial value of samurais alive played a role, and another coefficient that changed from exponential in general to the one that described a particular phenomenon. And he tried several values, but he found it boring. He tried to get a rule to be able to find out the coefficients, okay, in an effective way. So he invented a technique called least square minimization, that he wanted to minimize the square of the distance, because distance could be positive or negative. The line could be below or above, so it could be negative or positive. And doing this, in principle, you should be able to find out in an effective way the coefficients to match the equation and so have an equation that describing the phenomenon. He was a mathematician, so for mathematicians, equations are important in how to, even though we physicists make use of this, was a mathematician who developed the way to get equations from experimental data, uh, in an empirical way. Okay, so he developed this technique developed this technique, and it was so important at this time. So how to be able from experimental data to get an equation that describes the phenomenon that is included in all the scientific calculators. So I already entered the data, okay, the data of by changing, this shift between the time starts at 0, okay, and with the values of the SMRI alive, and the calculator is able to tell us the coefficients, the n0 for the equation with least square minimization, the least square minimization itself is able to give us 87.75, should be 89, so the fit tells this, and the alpha for the question, let me find that, is minus 0.66311. So the question that describes how the number of summaries alive using this technique should be 87.75, or decimal, but anyway, power 0.7631. Okay, when x is from 0 to 7 or whatever. With this equation we can predict, take into account that we need to readjust the day, right? Because I don't have another color here. I think I have it. Yes, I have the red. So the real mathematical time value, always starts at 0, not at 1. Okay, so 2, 3, 4, 5. That's some small detail. The numeration of time, some more detail. So this is what the probability predicted, and we can calculate how much this fit. We write it here. N0, n equal n0 exponential minus alpha t. Okay, predicts. Okay, and see how close this is n predicted, and you will see why it's so important. So let me get 5 times exponential of 7 2, okay, starting at 0.